Welcome to the Vintage Audio Workshop. Here we have the Quad Control 22 Pre-Amplifier, which is circa 1956. It's an all-valve unit, and it was continued for about 10 years until replaced by the fully transistorized model, the Quad 33. Here we have Phil Moss, who's going to take you through the circuit diagram and show you some of the work he's done.
The Quad 22 Pre-Amplifier. Now, we've done the power amplifier before, but we're showing you to start with the pair should you not be familiar and be watching this before the power amplifier circuit is done. Very famous amplifier. Nice neat little stereo control unit, and you would need two power amplifiers for stereo. No, it isn't intended to have two valves sticking out of the back. It's intended to have equalising units plugged in, which are chosen to match the cartridge that you're using in your record player and the tape recorder that you're using, etc. The three sockets on the right are for AM and FM tune, and you've got an auxiliary on there and possibly two FM tuners, because when this was designed it was believed that for stereo FM reception you would need two tuners tuned to different frequencies. Fortunately, someone had a very bright idea called multiplexing, and therefore one only needs one tuner with a demultiplexer to give you stereo, but that wasn't known at the time. There we have a close-up of the plug-in units. One of them is tape and one of them is for pickup. One of them is B9A and one of them is B7G. One needs rather more connections for one unit than the other, hence they had a 9-pin and a 7-pin. It also meant you couldn't plug them into the wrong socket, which would have given you a very interesting characteristics if you had a done. If you look at the far right hand side, you can see the mains 2-pin plug. They didn't earth these originally, even though it's a metal case. And in the previous picture there was a green wire in evidence connected to the earthing terminal because I put a 3-core cable on it. I think for safety one needs to do that, even though these units are not known for having breakdowns in the wiring making the chassis live, but it's a sensible precaution. So here we have a view that shows you the front panel, even though it's upside down, but you also get a view of the very neat interior, the right angle wiring and the nice layout. But also in the foreground of the underside of the chassis you see the horribly complicated push button switching. I have got a way round that, however, when it comes to explaining the circuit, so that we do not have to trace that through. That unit had, by the way, been to me for attention, and there are quite a few replaced components in it. This is the top, which looks rather nicer because there isn't all that wiring around the push buttons. So you see that there's a tag ball punched out above the pots for the wiring there. You can see that the input valves have screening cans on them, even though this unit is of course all metal with a metal lid. On the right hand side you have the two EF86s which have internal screening, but on the left hand side they put the ECC83s in cans. You will notice also on the left hand side there is mains wiring. That red wiring is the mains. The switch is on the back of the volume and balance pot. That is a triple pot plus switch in one piece. And you'll also see that there is a metal shield that covers most of it to keep the hum out. You can't see it, but there is a suppression capacitor, or there would have been a suppression capacitor on the left, just up by the front panel. Now I removed it because although it hadn't gone bang, considering the age of this unit, leaving in a capacitor between the mains and the chassis was a bit risky in case it blew up. They do tend to at this age. You can't blame them, having had the mains across them for many thousands of hours and being more than 50 years old. It could be replaced by a modern capacitor that meets the modern legal safety standards. So there is another clearer version over the top of the underside of the chassis showing clearly the switching and its complexity. This one has been to me, and there are quite a few replaced components. For instance, these orange caps, These are rather more rugged, the ends are rather less likely to drop off them. They clearly are not original because they weren't made when this was. Someone else had been in here, and those are not ones fitted by me, and the electrolytics that have been replaced are radial, that is, the wires come out at one end, not both ends. They don't really look that right in a quad, but the thing is, it's not easy to get axial components nowadays, and indeed these capacitors were intended for circuit board mounting. But these ones are much cheaper, they're easily available, and they work perfectly well. There are a few changed resistors in here as well. That one there, you can't see the colour banding, but in fact that's a high stab, so that there are 4 bands for its value, plus there's a brown one on the end for the 1% tolerance, and there's another red or brown for the parts per million thermal coefficient. This is a picture taken from the manual that came with it. Now, the quad manuals were very well written, and they were very useful. In those days they issued circuits with it to the purchaser, not just to service personnel, and they labelled all the components. You can see all the numbers around it and the arrows pointing to where they are, so if you wanted to find a particular component you could find it there, and then the arrow would show you where it was in the physical reality of it, and that's for the top of it, showing all the components, which is very helpful if you're not familiar with it. As is the fact that it has a proper parts list listing all the component values, but also the manufacturers. And that's another view showing you again labelling of the things that weren't clearly visible in the previous 2 diagrams. So they did a comprehensive job of this, showing you the layout. So this is the full circuit, and you might find it intimidating. It is not an easy circuit to follow. I have made it much easier, as you will see in a minute. Basically, I have taken the input section here and simplified it, because if you try following this circuit you'll probably finish up cross-eyed and disillusioned. The input stage is the famous EF86 low noise audio preamp valve with negative feedback applied around it according to what function. Just to make this circuit even harder to understand, of course, the equalization is mainly on these plugins that I mentioned before, so you can't even see the component values. The tone circuits and the filter are also not that conventional, and again there is a blown up diagram showing just one side of it. These 2 halves are almost identical. The difference is that you don't necessarily see all of the connections, so that part is missing on the lower diagram. That shows suppression components across the mains, and it shows the mains wiring. That won't appear on the diagram that I'm going to be discussing in detail. This is my simplified generic circuit of an equalized input stage. Ignore the values that apply. In fact, this was taken from a Heathkit circuit in the main. It was already drawn, and therefore it is being used again. If you look at the same kind of circuit by different makers, you will see that the values change. As far as the equalization is concerned, and we're mainly concerned with this one, which is RIAA for magnetic pickups, what matters is that the time constants remain the same. Depending on the design, they may want more or less overall gain, and they may just change the values anyway, providing the time constants, as I say, remain the same. That's the essential thing. So you may find wildly different values of resistor and capacitor, and you will find this same circuit of 2 pairs of parallel capacitor and resistor in series used in transistor circuits as well. But of course, for transistor circuits you would expect the resistors to be very much lower in value and the capacitors to be very much larger. So an explanation, you take a signal input here, there will be a switch that selects which input you connect to, and there could be lots of them. Magnetic cartridge, tape head, tape recorder, radio, auxiliary, microphone. On a modern one you may well have CD and video input and MP3. But the principle is the same. So we have a low noise amplifier. Notice the ratio of the anode resistor to the screen resistor. That will be between 5 and 10 times for minimum noise. In this case it's a bit more than 5 times. And that resistor certainly will be low noise. This one Mullard certainly recommend is a high stab as well. As I've said so many times, nowadays it's hard to get resistors that aren't high stabs. They're virtually all metal film and they're intrinsically low noise. This capacitor in many circuits would be rather larger than 0.1, but clearly Quad found that that was adequate to decouple even low frequency noise in this stage. The value of the bias components will change from circuit to circuit. 4.7 seems rather high to me, you might find lower, but obviously this works. And the capacitor is chosen to have a reactance that is very low compared to the intrinsic impedance of the valve and the value of the cathode resistor. Again, you may find that the grid leak resistor is a wide range, but it's simply a grid leak. So now considering the equalization. For tape recorder, for microphone, for radio, for CD, MP3, you just have a resistor because those inputs are pre-equalized if they need it. They are therefore tonally flat, so it's a question of gain. Almost certainly in those positions you will have a resistor in series with the input. Now, for some inputs you may also find that there is a pot on the input, because what constitutes a radio or tape output, or indeed in modern circuitry a CD, different manufacturers observe different standards. If it complies to DIN standards it will be between 50 and 100 millivolts. If it's a professional piece of equipment it may well be normalised to 0 dBm equals 0.775 volts. If it's a CD player it might be as much as 2.2 volts. So by giving you a pot on the input you simply adjust it so that you can use the volume control over a reasonable range of its angle and not have it all cramped at one end. The other thing is, of course, with high level inputs is to make sure that you don't cause distortion in the first one, which turning down the volume control somewhere later in the circuit will do nothing to prevent. For tape head, one has an enormous amount of treble cut and an enormous amount of bass boost. So we simply have a capacitor in series with a resistor. Now, for the magnetic input, the response is approximately flat around 1000. One has bass boost below that and treble cut above it. This circuit clearly gives a lot of treble cut because the reactance of 1000 PF at treble frequencies is a lot lower than the resistance of 10 megohms. But here it's a smaller capacitor but a very much smaller resistor. So that's the other end of the equalization to bring up the bass. The output would be taken from the anode as well. In fact, in the quad circuit it's taken from this side, so they used a 0.05 microfarad capacitor as the DC blocking capacitor for both the equalization and the feed to the next stage in the amplifier. Some have a separate capacitor for that from the anode for DC blocking. This is an expanded section of the circuit. As I said before, we would look at one of the channels only because they are electrically identical. So the signal comes in over here from the stage we've just looked at, the EF86, which of course in this amplifier had the complex wiring through the push buttons and the external plug-in equalization unit. We're now getting a flat signal coming in here. We have a straightforward voltage amplifier feeding a second stage here. Notice they don't decouple this cathode, so it isn't run at high gain. Also notice that whereas we've got 470k in the anode, which is very high, but then it is loaded by a grid leak that's 3 times the value. Here we've got 47k. This has got to drive the tone circuits. It has also got to drive the output. And whilst this doesn't have a low impedance output such as one would have in professional equipment, and it's not intended to drive a long cable up to the power amplifiers, one still wants the output impedance to be reasonable. So here we have the base control. So these two capacitors look like short circuits at treble and middle frequencies. So this is simply a potential divider of the base. At one end you get a highly attenuated output of the base because there's a large series resistance in series with the output, and at the other end there is no series resistance at all, and you get base boost. It feeds this inductor and the switch. Now this is the famous quad HF roll-off circuit. Using an inductor and a resistor, but also the capacitor. The resistor gives you the variable slope, but it's basically an inductance capacitance circuit, so you can get 12 dB instead of 6 dB per octave. You have 3 switch frequencies plus defeat. The defeat position also defeats the tone controls. So it's 5, 7 and 10 kilohertz that you can select for the high frequency roll off. At one end you're short circuiting the coil, and obviously there's no roll off at all. If one goes to the full 1/4 of a meg, then one has the full effect of the inductor and the capacitor. One then gets the treble control. Here we have blocking capacitors that keep out the bass and the middle, just the opposite of the bass control. And at one end again we have a lot of attenuation, the signal disappears at treble frequency, and at the other end we have a boost, and in the middle both of them are approximately flat. The signal is then fed out, and in fact we've got a fair amount of attenuation here with the 27k, and then we've got the 68k to ground, and the signal goes out on the 6-way connector that also brings in the heater and the HT. Notice that the heater supply is balanced. It is not earthed on one side, which would cause hum. Because they do their heater wiring properly, hum is not a problem in this preamp. You do not, as I've said before, have to have DC heaters to keep hum out. You just need to wire the thing properly. So that is basically it. There is obviously a balance control. That bit is missing on this circuit because one has to look at the full circuit for that. But that was so cramped as to be quite confusing. And one has a mono stereo switch. Indeed, they have some clever switching. So with 2 buttons, you can have normal stereo, reverse stereo, mono in the normal sense, or one channel fed to both outputs, or the other channel fed to both outputs. It's really rather clever. I once designed a circuit that did that, but it required a 12-pole switch and 2 wafers. Their system with just 2 push buttons is a good deal cleverer. But then I was only about 12 when I designed that, so I think I can be let off. I think that's it.
Our apologies for the generic circuit area, where Phil mixed up the quad values with the Heathkit circuit a few times, mostly being the C4, 6 and R8. In post-production we highlighted the quad values with red, just to clarify. Also, the AC main spike filter capacitors C32 and 33 are for the protection of the power switch alone, not for the circuit. This is to avoid the arc over on the soldered terminals at the back there. I think we should point that out. On a recent set we had to replace this component. We have 6 more videos of Phil in the edit stage, and we'll be posting these very soon. Up on YouTube so far there's 24. This will make it 30 in total, giving us 8 hours of material post-edit. I'd like to thank Phil very much for his effort, and this channel will be dedicated for the Filmos videos. On our website homepage at the top, there you can make a donation of your chosen amount to help support what we do, and hopefully we can get Phil back for the radio circuits. Phil is happy with the 23,000 hits he's had so far on the Quad 2 video. This has already been posted much earlier, and we're all glad to help as many people out as we can. Please hit all the buttons on the YouTube as we need your support with the growth of this channel. We have lots more content to follow concerning the audio circuits, and we'll be back for many more Quad update follow-up videos.